Welcome to the Goldwyn YouTube channel dedicated to education. We are thrilled to have you here as we embark on a journey into the world of knowledge and learning. Whether you are a student, teacher, or a lifelong learner, our channel is your go-to destination for valuable and engaging educational content. From informative videos on various subjects to practical study tips and strategies, we aim to empower and inspire you to reach your full academic potential. So, join our community of curious minds and let's dive into the world of education together. Remember to hit that subscribe button and never miss out on any of our insightful videos. Let's grow, learn, and succeed together.
Understanding rounding. Rounding numbers is a fundamental skill in mathematics and statistics. It is a common mathematical technique used to simplify calculations or represent values to a desired level of precision. In some cases, it is also important to consider the uncertainty associated with a value and round accordingly. It helps us simplify numbers and make them more manageable in various calculations. Today, we will explore the world of rounding and learn how to deal with uncertainty. Let's dive in. Defining rounding. Rounding refers to the process of approximating a number to a specific place value or digit. It helps us make numbers easier to work with, especially when dealing with complex calculations. There are several rounding methods we can use, such as rounding up, rounding down, and rounding to the nearest digit. Reference documents regarding uncertainty rounding issue. Number 1. From International Laboratory Accreditation Cooperation or ILAC policy documents. Name, ILAC Policy for Measurement Uncertainty and Calibration ILAC P14:09 2020. Number 2. Joint Committee for Guides in Metrology or JCGM. JCGM Publications, Guides in Metrology. Name, Evaluation of Measurement Data, Guide to the Expression of Uncertainty in Measurement. JCGM 100 to 2008, First edition, September 2008. Number 3. International Organization for Standardization or ISO Standard Quantities and Units, Part 1, General ISO 80001 to 2022. Number 4. Good Laboratory Practice, GLP, Procedure. GLP-9 Good Laboratory Practice for Rounding Expanded Uncertainties and Calibration Values, GLP-9 to 2019. Number 5. Physikalisch-technische Bundesanstalt DAX DKD Guidelines Rounding of Results and Measurement Uncertainties and Calibration Certificates, DKDL 13 to 3 edition, 11 2021. Rounding Rules. Now, let's discuss some rules for rounding numbers. These rules depend on the digit being rounded and the following digit. For example, if the digit following the one you want to round is 5 or greater, you round up. If it's 4 or less, you round down. Let's look at an example. 1. Rounding to the nearest whole number. If the decimal portion of the number is 0.5 or greater, round the number up to the next whole number. If the decimal portion is less than 0.5, round the number down to the previous whole number. Example, 4.6 would round up to 5, while 4.3 would round down to 4. 2. Rounding to a specific decimal place. Determine the desired decimal place to round to. Look at the digit to the right of the desired position. If it is 5 or greater, round up. If it is less than 5, round down. Example, rounding 3.14159 to 2 decimal places would result in 3.14. 3. Rounding ties. In case of a tie, when the decimal portion of the number is exactly 0.5, There are different rounding methods that can be used, such as round half up, round half down, rounding down, round half away from zero, rounding away from zero, or round half to even, rounding to the nearest even number. Example, 1.5 would round up to 2, and minus 2.5 would round down to minus 3. Rounding rules for uncertainties. Simple round uncertainties up. In reporting final results, it may sometimes be appropriate to round uncertainties up rather than to the nearest digit. Round uncertainties up to the next larger value when there are any digits beyond the second significant digit. This conservative approach may be used for reporting uncertainties, for evaluating compliance of the uncertainties against maximum permissible errors, tolerances, or risk assessments, including guard banding, and may also be used when reporting values on an accreditation scope. Example 1. Calculated value is 1.3578 mg and uncertainty 0.5775 mg for two significant figures. Reporting results will be 1.36 mg plus or minus 0.58 mg. Other example present at table. If you need information, please check ISO 80001-2009 Annex B, Rule B, DKDL 13-3, 2021 Clause 4.2, JCGM 100-2008 Clause 7.2.6, GLP 9-2019 Clause 2.3.
Thank you.